Hello, everybody. This is Miss Eubank. I hope you guys had a good time at the dance marathon. I can actually still hear you guys right now. Um, okay, so today we're going to talk about inverse variation. When we're done with this video, you should be able to state when a relationship is an inverse variation, calculate the constant of variation, and graph the rational expression. So a lot of these words don't really make sense to you, but hopefully after this video you will understand this a little better. So an inverse variation is in the form of y equals k over x. You can also write it as x, y equals k, where k is the constant of variation. So if you guys remember way back in the beginning of the year, you talked about direct variation, and that was it describes a linear relationship between two variables. Well, now we're describing a nonlinear relationship between two variables, and these relationships aren't going to look like lines. They're going to look like the graphs that we graphed way before uh, spring break. So this first one, this example, it says if y is 6 when x is 10, find x when y is 12. So the first thing we're going to do is set this up. So in the formula, y equals k over x. We're going to plug in our y. So 6 equals k over 10. We're going to solve for k, multiply by 10, multiply by 10. 60 equals k. So then it says find x when y is 12. So now we know our constant of variation, so we can plug this k in to solve for x. So we're going to do 12 equals 60 over x. Multiply by x. So on this side we get 12x equals 60. Divide by 12 on both sides. And x equals 5. So not too hard, we're just plugging in and solving for one variable or another. Okay, this next example, you have to tell whether the relationship is an inverse variation. Now, to do this, we're going to have to find the constant, and the constant has to be the same for each set of x and y for it to be an inverse variation. If they're not the same, then there's no relationship and it's not an inverse variation. So when we plug these in, 12 equals k over 2, multiply by 2 on both sides. So we get 24 is our constant. If we do the next one, 8 equals k over 3, multiply by 3 on both sides. This also gives us 24 as our constant. The third one, if we do 6 equals k over 4, multiply by 4 on both sides, k equals 24. So the constant is the same for all three sets of x and y coordinates. So this is an inverse variation. Yes. If one of these coordinates did not have their constant is 24, then there is not a relationship. Okay, now this example is going to help tie everything together that we've been doing. Okay, so It says, it takes 4 hours for 6 students to wash my car. If they all, if all the students work at the same rate, how long will it take 2 students to wash my car? So we're going to set it up like this. So we're going to use y equals k over x. We're going to plug in. Now, we're going to use our independent and dependent variables to know which goes for x and y. So our independent are our students. So let's see here. So let's write this down. Our independent variable is our students. I'm just going to put IND. So is our students. And our dependent is the time. Our independent variable is our x, and our dependent variable is our y. Okay, you guys should write this down because this can get confusing. So when we plug it in, we get 6 equals k over 4. Sorry, I just caught my mistake here, plugged in the wrong numbers. Y is our time, so 4 equals k over 6. We're going to solve for k, so multiply by 6 on both sides. So k equals 24. So if they all work at the same rate, how long will it take 2 students to wash the car? So students is our x, so we're going to do y. We want to know the time. So y is our variable equals constant is 24 divided by 2 students. So 24 divided by 2 gives us 12. So it would take 2 students 12 hours. And that's our final answer. Now, if we were to graph this, we would use the same steps that we used before spring break when we were graphing the rational expressions. So we'd use y equals, our constant is 24 over x. We find our restriction, x cannot equal 0. So 0 is our asymptote. So let's put that in there. Okay. Let's get rid of that one then. Okay. So we're going to graph it. We're going to make a t-table, x, y. Now, we were plugging in numbers less than the asymptote and greater than the asymptote. But in this case, since we're graphing and we're talking about real life situations, we only need the positives. So we're going to plug in, we can plug in 1, 2, and 3. When we plug 1, 2, and 3 in for x, first one we get 24, then 12, and then 8. So now we're going to plot these points. On the y-axis, let's go by 5. So make this 5, 10, 15, 20, and 25. Okay, so our first point is at 1, 24. Right about there. Our second point is at 212. Right about here. And our third point is at 3.8. All right, so we're going to draw our curve in here. And that is our graph. All right. So in class, we'll talk a little bit more about this and clear up any questions that you have. See you in class.